Hey there everybody, hope so everyone is doing great. So today in this video I will be discussing on random variables. So you might be having a question like what exactly is this random variable? So random variable is basically a rule that assigns to a numerical value to each outcome of an experiment or an event. So let it be a rolling a die or tossing of a coin. So both these experiment provides a random value. We cannot predict the exact outcome of these experiments. So in a case if you are tossing a coin, you cannot predict of 100% guarantee that you will be getting the head or you will be getting a tail. And the same case applies to the rolling of a die. When you roll a die, you are having a chances to have a 6 different outcomes ranging from 1 to 6. So in this case you cannot predict you will be getting a specified number like 4 or 3 or any number. So this is how a random variable, and this is what a random variable is. So now as we have seen, we might have like appearance of a value or getting of a value of like randomness. So now this situation we can see in a rolling of a die where you may having a higher chance that you may get a different value than you have expected. And similarly temperature that is measured at the noon time, and same thing applies for the time it takes to solve a puzzle. So everybody cannot have the same time or the same pace to solve a puzzle. So a different guy with a different set of experience takes a different amount of time. It can be like he may take a less amount of time or a higher amount of time. So this thing is completely or entirely random. So we cannot judge or specify it and provide like exact value. Everybody can solve this puzzle within 5 minutes. So it's not going to happen. So now let's come to the type of random variables. So now when it comes to random variables, we mainly have like the two types, that is the discrete and the continuous. So when it comes to discrete, so we can take a finite or countable number of the values in the discrete, but when it comes to continuous, so we can take any value with a given range. So for the discrete, the best example we can take is a number of cars passing a checkpoint in an hour, or a coin toss outcomes. So the best example we can take for is like a coin toss outcomes, whether it is a head or a tail. So we can easily judge it and it's easily countable. And when it comes to the continuous thing, the best example what we can give is height of a person and time of completion of a marathon and a temperature fluctuations. So these provide a like variety of range, and it is not like the head or tail where we have only two possible values, that is like a true or false. But in this continuous thing, it is entirely different. So you got a certain set of range. The best example we can also take is the height of a person. So when you give a range of height, so a person can range from an average of 4 to 6 feet, or it can be 7 feet, and even a person can range from 6.2, 6.3 or 6.4 feet. So this is how the continuous thing works. So next up is the probability distributions. So what it does is it basically describes the probability of each value occurring in a random variable. So if you take a discrete thing, so it is represented by a probability mass function, also known as a PMF. So assigning a probabilities to each value. And when it comes to continuous, it is represented by a probability density function indicating the probability density at each point within the range. So then we have like common discrete distributions. So when it comes to common discrete distribution, we have again the binomial, the Poisson distribution, and the geometric distribution thing. And what does this binomial do? Let's take a look on this. So this binomial for experiments with binary outcomes such as the success, failure, and it is fixed number of tails. So the best example we can take for this can be the tossing of a coin, where we have like the heads or the tails. So and for the Poisson distribution, we have a like fixed number of events occurring in a fixed interval and assuming a constant rate. And the next up is the geometry. For this number of trials, we need to achieve the first success in a Bernoulli trial. Next up we are having common continuous distribution. So again we are classified here into three types, that will be the normal Gaussian, the uniform, and the exponential. So what is this normal Gaussian? So normal Gaussian is just like a bell-shaped curve we can take as an example. So which is widely used for modeling the natural phenomenon and human characteristics. And when it comes to uniform, so equal probability for all values within a range. And we have a exponential, so the time between the successive events in a Poisson's process can be classified for the common continuous distributions. So now as we have completed all the concepts of the random variables, let's explore the applications of the random variables. So random variables are applied in the various fields of the industry. It is not limited to like one or two. So but the major industries or the major fields where we can see the use case of the random variables will be financial, healthcare and the engineering fields. So when it comes to financial field, so it plays a major role in the modeling of the stock market prices, where the people can know what is the rising stock and what is the falling stock, and so that they can invest in the company accordingly. So this plays a crucial role in the financial sector. And similarly in the healthcare industry, when there was a outbreak of the coronavirus, scientists were able to predict the growth and the spread of the virus with the help of this randomness thing. So this has played a significant role in the healthcare industry. And when it comes to engineering, so the quality control system, reliable analysis, it can be the simulation of a complex system, which has also helped in the major part of the development of the technologies, and also helped us in the advancement of the technology for a faster growth. So that's it guys, that's it for the session. Thank you. If you like the video, make sure you like it and also do subscribe.